The military convoy stopped at kilometer 47, not because of enemy contact, not because of mechanical failure, because the ground itself had become something no vehicle in the convoy was rated to cross. 3 armored trucks had already sunk to their axles. The 4th had jackknifed, trying to reverse out. The mission was 12 hours from collapse. And then a single civilian vehicle rolled past all 4 of them. It did not slow down. It did not hesitate. It crossed the same terrain that had swallowed for military vehicles, and it kept moving. That vehicle was not built by a defense contractor. It was not developed under a military program. It was built by Toyota, and it was a motorhome. That event did not make the news. Events like that rarely do. But within engineering circles, within the communities that build and test extreme expedition vehicles, that story circulated fast, because it revealed something the defense industry has been reluctant to admit for years. The gap between military vehicle capability and the best civilian expedition engineering has been closing, and in some categories, it has already closed completely. The assumption most people carry is that military means maximum. If the military built it, it must be the toughest version of that thing. That assumption made sense 20 years ago. It no longer holds. Military vehicles are built around procurement systems, budget cycles, political contracts, and standardization requirements that slow innovation to a crawl. The best civilian engineering operates under no such constraints. When the goal is pure performance in extreme conditions, civilian builders with serious budgets and no bureaucracy have been producing results that defense contracts simply cannot match. The Toyota SHIELDBEAST is the most extreme proof of that reality that has ever been built. 12 by 12, 12 wheels, all 12 powered. The step up from a 10-wheel drive system to a 12-wheel drive system is not a small increment. It fundamentally changes what the vehicle can do on terrain where weight distribution becomes critical. A 12-point contact system spreads the vehicle's mass across a larger footprint, reducing ground pressure at each individual contact point. On soft terrain, lower ground pressure means the vehicle floats where others sink. On uneven terrain, more contact points mean more grip, even when multiple wheels are simultaneously off the ground. The 4 armored trucks in that convoy were running 8-wheel drive systems. They were exceptional machines by any conventional standard, and they still sank. The SHIELDBEAST did not now consider what Toyota brought to this engineering challenge that no defense contractor could. Decades of drivetrain development in the most brutal off-road environments on Earth. The Land Cruiser program alone represents more accumulated real-world terrain data than most military vehicle programs have ever collected. Toyota knows how drivetrains fail. Toyota knows exactly what components break first, under what conditions, and why. That institutional knowledge is embedded into every element of the SHIELDBEAST's mechanical architecture. The transfer cases, the differentials, the axle housings, the suspension geometry. None of it was designed in a laboratory environment and tested on a proving ground. All of it was developed from decades of feedback from vehicles operating in exactly the conditions this machine was built to dominate. The engine produces 1,200 horsepower, but the number alone tells you nothing useful without understanding where that power goes. The SHIELDBEAST runs a dual-engine configuration, 2 separate power plants operating in coordination, each responsible for driving one half of the 12-wheel system independently. This is not redundancy for its own sake. It is a strategic architecture. If one engine is damaged, shut down, or running at reduced capacity, the other half of the vehicle continues to function at full power. The vehicle does not limp. It does not stall. It splits its capability and keeps moving. In a military scenario, that architecture is the difference between a mission asset and a mission liability. Here is what almost no coverage of this vehicle mentions. The SHIELDBEAST's chassis flex tolerance. Every vehicle bends under load. The question is how much, in what direction, and whether that flex destroys the integrity of the systems mounted to the frame. Standard motorhome platforms are designed for torsional rigidity on paved roads. That same rigidity becomes a catastrophic weakness on extreme terrain, where the ground itself twists the vehicle in 3 dimensions simultaneously. The SHIELDBEAST chassis is engineered with controlled flex zones. Specific sections of the frame are designed to absorb and distribute torsional stress, rather than resist it. The vehicle moves with the terrain instead of fighting it. That compliance is what keeps the systems inside the plumbing, the electrical architecture, the structural walls intact after thousands of kilometers of conditions that would crack a conventional chassis like a dry branch. The living quarters inside tell you exactly what kind of missions this vehicle was built for. There is no compromise between functionality and survivability because the designers never treated them as competing priorities. The primary operations area features workstations rated for simultaneous multi-person use during active vehicle movement. Not parked, moving over rough terrain. The displays are mounted on active damping systems that absorb vibration before it reaches the screen surface, so situational awareness is maintained even when the ride is violent. The medical bay is stocked and configured for field surgery capability, not just first aid. The sleep quarters are acoustically isolated to a level that allows genuine rest during active operations. when the vehicle is running systems overnight. Every detail in that interior answers the same question. What does this crew need to remain fully operational for 30 days, in complete isolation from any support structure? The communication and navigation system deserves its own conversation. The SHIELDBEAST operates on a triple redundant communication architecture: satellite primary, high-frequency radio secondary, mesh network tertiary, connecting automatically to any other SHIELDBEAST unit within range and creating a shared operational picture across multiple vehicles without any external infrastructure. The navigation layer integrates live satellite imagery with preloaded offline terrain mapping and onboard sensor data to build a real-time picture of what is ahead, not just where the vehicle currently is. This is not GPS. This is predictive terrain intelligence. The system flags potential hazards before the vehicle reaches them, giving the crew time to route around obstacles rather than react to them at speed. Now here is the reframe that changes how you see everything we have covered. The 4 military trucks that sank at kilometer 47 were not failures of the crews driving them. They were not failures of maintenance or preparation. They were failures of the systems those vehicles were built on. Systems that were good enough for the threat environment they were originally designed for. In a world where extreme terrain was considered a limiting factor rather than an operational parameter, the SHIELDBEAST was built on a completely different premise. Extreme terrain is not a limiting factor. It is the operating environment. Design accordingly. That single shift in design philosophy is what produced a civilian motorhome that crossed ground, that stopped 4 armored military trucks. And that shift is now spreading across every category of extreme vehicle engineering because the results are impossible to ignore. The organizations already using platforms at this level are not talking publicly about what they are discovering, but the lessons coming back from those operations are beginning to reshape what the next generation of expedition vehicles will look like. 12-wheel drive was a ceiling 5 years ago. Today, it is a starting point. What comes after it, and what the teams pushing these machines into environments no vehicle has reached before, are finding on the other side of that frontier, is a story that has only just begun. That if you want to be the first to understand where this engineering goes next, and what the machines being developed right now are being designed to survive, this channel is where that story gets told first.